Okay, so hello again. So we will resume the panel. So the panel two, search and rescue. So the next, please. I'm very honored to introduce the four distinguished speakers. Yes. So next, the first panelist and moderator of this panel is Commodore James Fanshaw. Uh, Commodore James Fanshaw will talk about search and rescue from UK maritime industry. The title is The Input of Unmanned Vessel to Operations. Next, please. Mr. Hernandez Frad is coordinator of the Sprinter Group of Mass Correspondence Group on SIR and will address the search and rescue issues from mass regulation perspective. The title is Mass and SIR, Traditional Duties and New Technology. Okay. Next, please. Mr. Roland Mackey will discuss the positive and negative search and rescue impacts of these vessels and the desired capabilities and requirements to ensure effective SIR response. The title is The Search and Rescue Impacts of Autonomous and Remotely Operated Vessels. Next, please. Mr. Richard Robertson will look into the challenges of salvage and autonomous ships and opportunities to better prepare these vessels from the view of salver. The title is Autonomous Ship and Salvage. So the floor is yours, James, please.
Thank you. It's very nice to be back here at JAMS in Japan House in London. I remember the first one last year with affection, and it's a great honor to have been invited back. I didn't know I was going to expect to have that honor. As you can see there, I do two things. I chair the UK MAS Regulatory Working Group that is responsible for the code of practice that you can see on the Maritime UK website. That is over a decade of hard labor, where I've labored over all sorts of questions. And for somebody who asked it earlier, quite a lot of work on the pilot side of life, and I'm happy to discuss that out of this committee. But the UK MAS Reg Group was formed when there was a gap. Not many people knew how to spell autonomy, never mind what it meant. And these days, you know, half the world seem to be piling in with some way of doing this. Now, the other thing is that I'm not just a talker about it and a writer of it, I also do it, and I'm a director of Zulu Associates. And to put that into context, we're at the moment in final design and about to build this year two types of vessel. One is a short sea, that's a 100-meter, 200 TEU container, unmanned, electric, zero emission for short sea operations. That takes all this into a completely different ballgame. And, you know, when you see the very interesting report we had earlier of IMO, you have to remember that that starts at 24 meters. So all the current crop of unmanned vessels are generally less than 24 meters. And what I'm involved in is the whole business of jumping this up to 100-meter container vessels. It's a fascinating part of the world to be in. And we're also doing inland waterway stuff. For what it's worth, I also moderate the UN at UNECE on inland waterways and autonomy. So let's set the scene. Now we're sitting here, all of you out there in Cyberland are watching in front of your computer, and I'm going to now take you to sea. So if there's any chance we could go to the next one and roll the video, I'd be very grateful.
Mayday, 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 mayday.
These are the most dangerous waters in the world.
As just a reminder that as we sit here in a nice, calm, peaceful office, and all of you out there in your offices or your where your computers are, life ain't like that at sea. You know, I've fallen off 40-meter waves in my 35-year seagoing career, and I've done a lot of SAR work. I suppose at one end of the spectrum was Herald of Free Enterprise. That was me. I was there picking up 190-something very sad, tragic bodies from the ferry that went over opposite Brugge. And I've done lots more, much smaller SAR operations, including trying to rescue 4 individuals off a rock off Devon who decided it was safe to go to sea in a rubber boat and an AA road map. They soon learned that it wasn't. I'm going to rattle through the requirements for SAR within international law. It's already been covered in my illustrious panel, and they've all got really interesting presentations. They know what they're talking about. I'm just the gaffer. But you know what Article 98 says in UNCLOS. I put it there as a scene setter. And if we go to the next slide, you can see the applicability as I would see it. Can you push one? So the international state obligation is to be practically discharged by the master of a ship rather than the ship itself. And if you remember, we had an interesting report from the IMO world where it is the vessel, not the individual, when it comes to height, sight, and sound. Though, therefore, the duty cannot lie with the mast, but potentially to persons operating it. Push, please. Of course, the mast is itself a ship. This is hotly contested. If you go to Colraigs, it's a vessel, and if you go to Solas, it's a ship. I'm not going to go there today. It's too much of a nice day. The one thing I would stress is that at any time, it needs to be clear who is the master. And you need to be aware of that when it comes to an incident. And I've seen various references to this already today. But there is the definition of master under the Merchant Shipping Act. This is UK. And that's the person with the command or charge of a ship. And in my code of practice, we actually define this for mast. Right, on we go, please. Right, search and rescue. So let's zero in on this particular aspect of life at sea when it all goes wrong. What is more significant, searching or rescuing? Push. Once the casualties have been found, there are lots of ways they can be rescued. And I put up a picture I actually showed last year of Susie Goodall being rescued in the South Pacific, 2,000 miles from Cape Horn, back in 2018. But you know, finding where people are. I remember getting an SOS call on VHF, channel 16, and because I had a DF in a frigate, direction finding equipment, I was able to say that it was down that bearing rather than the opposite bearing. So we drove down and we found a yacht in very serious distress, and indeed we did a rescue. But I would argue that very often it's the search phase of SAR that is more difficult and potentially more complex than the actual rescue once you know what you're dealing with. But time is going to be of the essence. I don't need to explain to you all how long you have to survive in waters in the, say, North Atlantic in the winter, but it really is not very long. It's minutes, particularly if you were thrown over at a time when you are inappropriately dressed. Okay, yes, please. These two guys I found on the web, both dead. They both died as a result of man overboards. And there you can see some statistics. We've seen these in different forms earlier today already. And you know, in 22, you look at the number of accidents recorded, number of vessels lost, and the startlingly high number of crew fatalities. And those are IMO figures on the right there in the box, you know, about 75 to 90. Please have a very large helping of caution with these figures. If you are driving a ship down a narrow channel and you have a steering gear failure, that is technically a technical failure. And how quickly the humans on board react to try and keep that ship in the channel and not to run aground and block it, sometimes is up for debate about whether human error was the contributory thing or actually it was the technical failure. Anyway, moving on from there, that tragic side. This, again, I was researching for today, and I thought I'd just look at what's known as the Marine Accident Investigation Board investigations. These are live vessels. You can see the vessel names down the left there, the Nista, the Amadeus, and so on and so on. But have a look at the incident. For anyone who doesn't think that this is really something we have to play as much of a part in with autonomous unmanned vessels as we possibly can do, these are the stats that actually show you that we have to do it as best we can. And if there's no one out there to rescue these people, they haven't got a dog's chance in hell. But if there happens to be some kind of autonomous vessel, we need to make sure that they can do as much as possible. Note the dates of these things. Oh, that's only October onwards to December last year. Those are very, very current. Okay, let's shunt on, please. So, just to remind you, and I'm sure I don't really need to, you know, what are unmanned USVs, MAS, actually doing? Commercial operations is very soon coming, and I'm very much part of that. Oil and gas work, it's already there, MSR, all those subsets of marine scientific research. Underwater asset management, somebody mentioned earlier pipelines, it's very real. Defense, 10 years ago, defense weren't really very interested in unmanned stuff. The Americans now have Task Force 59 in the Middle East, which is an unmanned task force. And this week, they have created a new branch in the American Navy, which is robotic warfare. And you can see pictures of what the badge on their arm looks like. Oh, I've been told I've got 10 minutes left. Thank you so much. And then, of course, there's maritime and border security. And finally, and I highlight it really, it's comms relay, because as you'll see in a minute, you know, you've got a hell of a lot of communications in these vessels. Right, let's move on. Otherwise, I'm going to upset the Japanese. Right, here are some ships. You've seen some of these before. The one in the middle top is Seekit Max Lima, which I have to pay deference to Nippon Foundation. It was the X Prize winner, which Nippon funded. And for fun, I've put the Zulu Mass. That's what we expect our 100-meter container vessel to look like. And note that we have wind power on top as well. And note that there is no bridge. There are no people. Next, please. Max Lima, there she is. Quickly on to the next one. The only reason I wanted to show this, yes, please. You know, very long endurance. She can stay out there for ages and stay within 2 meters if she needs, and so on and so on. But the next slide is the interesting one, because these are the sorts of bits of kit that you see on what is now a vessel that is 5 years old. I don't want to go through them, but you know, you've got EOI, ARFLA, blah, 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 blah. You know, you've got a hell of a lot more kit, sensors and comms than you have on the average tramp coastal 30-plus-year-old vessel. And this is very important because it needs to be used. It's there for operational reasons, but it can be used for SAR or any other purpose that it may be called forward. Yep. Just very quickly, anybody put their hand up and tell me what that is? That's Air France. That's Air France sitting on the bottom of the Atlantic as found by a UAV, Remus, and there on the left an ROV. The only difference with an ROV and a UAV is a tether, which is what you can see in the picture there. But that is thousands of meters down in the Atlantic and huge capability. And it's all part of SAR, in my opinion. Right, on we go. The air world are there, various bits and bobs of equipment, and there's an awful lot of work in, rather euphemistically called drones. And you can see possibility to drop life rafts and life belts and so on and so on. I only put that in for completion because we don't be too focused on just the ships. Okay. My own function over the last decade has been putting together the UK industry code, and we published version 7, which looks like this, last November. Yes, please. There it is. You can find that online on the Maritime UK website. Anybody wants to ask me afterwards how to find it. But it's 140 pages of useful stuff. It's not law. It's guidelines, it's codes, and of course we're all waiting for the long-awaited IMO voluntary mass code to come out later this year. Okay. Here's a view into what I called remote control stations. Forgive me, we've got a bit confused now with ROCs and RCCs and so on and so on and so on. But these are various versions of them. You can see they're high-tech places somewhere ashore. Actually, they might be afloat. There's no reason why you can't have one of these things in a mothership. Okay, it's a quick snapshot. IMO instruments, I put them up there. You've already seen lots about them. Let's move on. The class societies are very active at the moment. I'm about to get a red flag from the front here. But the class societies, I'm working very closely with personally, and also with the flag states in various countries. And there's just a summary of the class societies. Can we go forward? The insurance. Companies like ship owners produced a very early version of the liability insurance from the P&I side. I think in deference to the earlier speaker, I've been involved in quite a lot of discussions about the role of cyber and autonomy. People are a bit nervous. Oh, I've got 5 minutes left. Turn it round so they can all see. But I just want to stress that a lot of work is going on in the insurance world, and specifically in relation to cyber, which is not the threat that you might think it is, and I could justify that in questions if you want. Right, on we go. And the human element, here we are. It's been stressed enough times today. You can't just consider the ships alone, and there will be plenty of jobs, but they will be different to the ones that we have today. Okay. So in sum, reach the summary. You've still got 3 minutes on the clock. There are a lot of ways that I would expect maritime autonomous systems. So that's the combination of the vessels out there and the control centers, the ROCs, the RCCs. One of the things is that they tend to go out there and stay there. They don't have to come in for weekends. We in the industry are making huge efforts to show responsible attitudes. And one of those, for me, has always been the fact that we should not expect the rest of the maritime world to barge over and change just because mass is on the scene. That is the wrong approach. We've got to find our way into an order that it has existed for decades, centuries. And there are lots of guidelines and standards that we can now begin to clutch onto, and hurrah for the voluntary code when it comes out. Please don't make assumptions about autonomy. Quite a lot of people make assumptions and make false statements. And I can't stress highly enough that there will always be a mix of vessels at sea. So when it comes to SAR, there may well be a manned vessel somewhere quite close as well. Doesn't mean to say that the mass can't do something to help. And safety is what comes first. Okay, thank you. Right, for those of you who speak Japanese, there's my attempt at some Japanese. But I'll be around later, and I'll be here tomorrow as well. Now it's my great pleasure to introduce Aman the Friar, who's going to talk to you, and I'll leave him to explain what his topic is going to be. Thank you very much indeed.
So, well, thank you very much for invite the Spanish Maritime Administration to come to this seminar. It's a true pleasure for us just being here. And well, next slide, please. The presentation will address a few issues. The first is the question of the search and rescue function from a mass regulation perspective. Is a more legal approach here in this presentation, so it will be more boring than my president. So some remarks will be done about the legal regime of search and rescue. The main issue to be addressed is the impact on SAR of the mass. And we also pay attention to the IMO development of mass regulation, and specifically we'll put a special focus on the IMO mass code and the work carried out at the splinter group on search and rescue is in developing this part within the mass code. So, well, next slide, please. First, just to carry out some legal remarks on SAR. So the first is the international law sets the duties of states on ships relating distress situations. The first is that the question is that the duty to render assistance to persons in distress at sea is included not only in conventions. It's also a traditional duty included under customary law. It can be said it could be considered a rule of jus cogens. What it means, these are this kind of obligations that are over the rest of mandates. For instance, like the interdiction of slavery or the prohibition of genocide. So the duty to render assistance at sea could be among these rules of jus cogens. So originally, the duty to render assistance was a duty for shipmasters. It was pointed out by James before, but it evolved to a duty for the states. Now these states shall ensure that the ships flying this flag comply with this duty, and also they have to have a search and rescue service at waters within their vicinity of their coast, even in maritime spaces that are not under their jurisdiction, that it may happen in the high seas or also in the other states' exclusive economic zone. So next slide, please. So just going to the main conventions that treat the question of search and rescue and the duties that established for states and persons also, the main international law instruments are set on these conventions. First, the UNCLOS, as it sets the framework for for the uses of the sea, and also establish some duties. Also, SOLAS is the main reference convention. It's a cross section because it talks different topics on safety on different chapters. The SAR convention set the scheme of the SAR service. The Salvage convention includes also some references to search and rescue. The COLREX established the distress signals to be known about the search and rescue. The ITU regulations set frequencies on some duties also, and we shall consider also there exist some regional agreements that treat the issue of SAR and can be considered a source of law. So we can see that these instruments, the duties that they set, they can be divided among those of the states and those of the ships. On the side of states, there is the availability of services, the infrastructures they should have, and the coordination. It's included on the UNCLOS and the SOLAS Convention and the SAR Convention. And on the side of the ships, there are the duties to render assistance and to coordinate with the coastal states. It's set in UNCLOS, SOLAS, SAR, and Salvage. Next slide, please. But first, just considering and going back to an issue that James pointed out, is a MAS a ship? We know that conventions deal with ships compliance, but at the time of the completion, the ship were manned and were controlled from on board. Neither UNCLOS or SOLAS or SAR include a definition of ship or vessel, so we cannot rely on this convention. On the other side, Colbert does. And vessel includes every description of watercraft, including non-displacement craft, rigs, crafts, and seaplanes, user of capable of being used as a means of transportation on water. Also, going back to the principles in international law, according to the Vienna Convention on the Law of Treaties, the interpretation of treaties shall be done in good faith in accordance with the ordinary meaning to be given to the terms of the treaty in their context and in the light of its object and purpose. And also shall consider that the supplementary rule of interpretation indicate that in case of application of main rules leads to an ambiguous and obscure meaning, or the result is manifestly absurd or unreasonable, could resort to the preparatory works and the circumstances of its conclusion. So maybe some doubts may arise when considering if a ship without crew on board or remotely controlled or by artificial intelligence are in compliance with international conventions. Notwithstanding, IMO addresses this issue through the regulatory scoping exercise, but we will revert later to this point. Next slide, please. Yeah, going into the SAR issue, first we should analyze the relationship between mass and safety. The introduction of mass is a new realm on navigation with the possibility of ships control from other location or by artificial intelligence, or the lack of persons on board. So as a matter of principle, we shall consider that the mass should be as safe as a conventional ship. Maritime safety is an ambiguous concept, but includes not only the ship safety, but the safety of navigation, the safety of human life at sea, among others. And it's all related also with the protection of marine environment. And going to the question of the safety of human life at sea, it's included the life of the crew of the ship, but also and the passage of the ship, but also the persons in distress. So search and rescue is included within the matter of safety. Next slide, please. The second step here is just to consider the relation between mass and search and rescue. We shall consider the main duties related to search and rescue are the duty to render assistance and the coordination of search and rescue. The coordination doesn't pose an initial problem. Always say that the communications are ensured between the ship and the MRCC or the ROC, or the remote operation center that controls the mass. But the duty of render assistance is a bit more complicated issue. Just first, is in the case of a mass with crew on board, there should be a difference with a conventional ship. Next slide, please. But what happens on a mass without crew and its relationship with SAR? So the main duties of SAR are the duty to render assistance and the coordination. Sorry, the next one. Yeah. So first is consider the operational envelope of the mast, the limitations the mast has itself, and also that in case of no crew on board, the rescue operation may be difficult or even impossible. We can arrange systems to retrieve persons from survival craft or from the water, but maybe cannot be used in the case of the persons in distress are exhausted or unconscious. So other question that may arise is that when persons are rescued, could be the mass considered as a place of safety according to the annex of the SAR Convention. And related to this issue, should the mast have a space where rescue person can seek shelter from weather? Next slide, please. So in this regard, we shall consider that what means to render assistance. And first to ask ourselves, are there limits to the duty of render assistance? UNCLOS and SOLAS indicate that it doesn't assist this duty in 3 cases: danger to the ship, crew, passengers, if the ship is informed that the need of assistance is not suspected, and if the ship receiving the distress alert is unable to proceed or is unreasonable or so on. Next slide, please. So we can go to the issue, which specific assistance of a mast can be considered. There are 2 opposing views about if a mast could render without crew could render assistance. The first is stable. It will be fulfilling the duty as the rest of the ships, as a conventional ships. But if we consider it couldn't, a mast could not be as safe as a conventional ship. Just going back to the rationale of being safe for the rest of the people on the sea. So it also, if a conventional ship has the duty to proceed to render assistance and a mast is not considered because it's not able, it may pose a competitive advantage of mast against conventional ships. But also, if you consider other ways to render assistance, if a mast cannot rescue the people from the water, it can be used for other activities related to mast other than rescue. For instance, temporary shelter, locating persons on survivor crafts or in the water, on a scene commander, refueling or stop for helicopters, communication relays, towing life raft or lifeboat, firefighting. But I mean, Roland will address this issue later. Next slide, please. And also related to that, we shall consider some issues of responsibility. The first to consider is the duty is not the successful result of rescue, but the use the endeavor to fulfill it. So in this regard, could the remote master at the rock be responsible for not rendering assistance when a distress call is submitted and received? And in the case that we think it's our zone, the service of a coastal state requests a specific assistance of the ship. And also, if found liable, what happens if the master is on a rock other than another state that the flag state? Well, I mean, these questions of jurisdiction will be addressed at the next legal committee of IMO to be celebrated in April. That is an important issue, this question of responsibility, the case you're not fulfill the duties you should comply with. So, yes, the next slide, please. Just ending this first part about the general remarks on MAS and SAR. Also, just to outline some specific procedures that may imply the use of MAS in search and rescue operations. For instance, is the question of contact or the communications between the MRCC and the rock. Should they be direct or through the MAS? I mean, it doesn't matter. The effective communications will be the issue. Also, to address, in this case, which kind of assistance a MAS could render. So rescue, relay of communications, search, whatever. And also, the third point I may outline that will be more for sure is the question of aircraft rescue operation and MAS can be used to stop or disembark rescued persons or used to refuel or many other issues. So, well, next slide, please. Just ending this first part, just going quickly to the second part related to the works of IMO in relation with MAS, with a special focus on the search and rescue issue. Next slide, please. Well, this has been pointed this morning by Mr. Harada from IMO, the question of the regulatory scope and exercise. At this point, I'm going to be fast because it talks very, very well about the issue. So, I mean, the specifically on the search and the SAR conventions, the outcome was that there were some gaps that should be addressed and that will supplement SOLAS. To carry this duty, this question and many others related to the other conventions, the mass correspondence group was created, and also there was created the joint working group MSC-LEC-FAL just to check the consistency between committees. Next slide, please. But well, going back to the question of the outcome of regulatory scoping exercise on search and rescue, there were different observations related to the level of autonomy of the MAS, and there were also potential gaps and themes and relevant findings. And in this regard, interpretation will be an alternative way to address the problems on search and rescue convention. First is that the question of considering this issue is that the terminology of the search and rescue convention is human-centric. So it needs to be addressed and adjusted just to be put in contact with the MAS. And also that the purpose of SAR system and emergency phases is to rescue persons. So any work on this regard should remove ambiguity. It's just if we have a MAS without crew on board, it cannot be in distress. Could be an issue to consider in the question of places of refuge or whatever, but not in the question of search and rescue. It's also pointed out that the MAS at this point was considered the MAS to perform as a SAR facility and on-scene commander or alerting post, and also treated as the rest of the sections addressed of the regulatory scoping exercise, the question of the meaning of master and the master responsibility. And also the question of, as I pointed out, the rescue and distress related to MAS is inconsistent. So next slide, please. About the MAS, MSC MAS correspondence group, as you see, I'm going fast on this, was established in May 22, is Marshall Islands coordinating, and the works are being in progress. Next slide, please. The main task is the MAS code to be delivered by the end of this year in a recommendatory version. And now it has three parts. First is introduction, same main principle for MAS and functions. And the third, that is on the works in progress now, is the goals, function, requirements, and provisions. The mandatory version of this code will be available expected by 2028. Next slide, please. These are the different parts of the MAS code. I'm not going to enter, but for instance, Japan is coordinating the part of navigation. Spain is coordinating the search and rescue part. You can see there are many, there are relations between parts. Next slide, please. And the search and rescue swinger group on section 10 on SAR, Spain coordinates, but we have the first France collaborating, later Finland, later Japan, now Norway, and the International Chamber of Shipping, CERM, and IMCA are inside the group. Next slide, please. On the section 10 contents, initially we outlined it at three parts, but it has been completely reformed and refurbished after the goal-based standard expert made a revision of the text. So we have a complete new part that will be delivered in the next MSC meeting in May. And the next steps, on this slide, please. The next steps for the Splinter group is just to merge some functional requirements within the part, to adjust expected performance, identify other additional hazards, revise the type of assistance a MAS could render. This is an important issue. To check consistency with other sections of the MAS code, and a new revision after that of the goal-based expert. So next slide, please. And just arriving to the end, I mean in time, the conclusion are there are some specificities, of search and rescue applied to MAS. There are two trends about if a MAS is able to render assistance. And if so, the type of assistance shall be defined. The communications shouldn't be a problem. If there is a effective communication through the mass or through the rock, it doesn't matter. There is a great collaboration among states on drafting the mass code. There is a very rapid evolution of tests. I didn't bring the actual test because it's gonna be changed in the next weeks. And the main issue is that the delivery of a recommendatory mass code by the end of the year. So next slide, please. So just came to the end of presentation. Thank you very much for attention, and we'll be able to ask any questions you may pose later. Thank you.
Apparently this is live. Oh, it is. Oh, well done.
Thank you.
Thank you, Spain. Now we're going to go to another one of our experts, to Rennie McPhee, and he's got years of search and rescue under his belt, and he's going to expand on what we've just said and put a slightly different view on it. If I could ask the organizers to come and help me to turn my computer from Japanese into English, I'd really appreciate that. Where you go, really? How do you make that?
So I'm going to talk about what
No, I don't.
Okay, it wasn't on, sorry. So the search and rescue impacts of autonomous vessels, and there may be benefits as well. So we're looking forward to that. IMO has made it clear that a MAS shall respond to search and rescue. It's pretty simple. We've heard other people talk about that today. There will be a duty to render assistance. We've had a little bit of debate about the ship responding versus the duty of the master. That can be sorted out, but they shall respond to distress situations. And to coordinate with the SAR service of the coastal state, that's very important. Ships must work with the SAR coordinators. We have a very well organized international system for the coordination of SAR, and we have to work together as a system with components. I won't read these, but the IMO has issued functional requirements for MAS. And one of the things that concerns me is the statement, keeping in mind its operational limitations. I think we need to be very clear that I think we are talking about that here, that MAS must be able to deliver some search and rescue capability. We can't allow MAS because it has an operational limitation, unless that's a breakdown of some system or equipment, to not respond to distress. This is the normal SAR process. So those of you that are familiar with this will understand we have distress alerting of nearby ships and shore authorities. So the MAS must be able to receive alerts. We have SAR communications between survivors, the responding vessels and the RCCs. So the MAS must be able to be involved in that process. We have information gathering. The MAS must take in information and send that information to the RCCs. Information sharing, analysis, management, decision-making. Currently, we have crews on board ships which can make decisions about responding and doing SAR operations, but we must make sure the MAS can be part of this process as well. Locating and detecting survivors by ships, the MRCC. So the MRCC needs information, possibly from the MAS, to develop search plans and then deliver those search plans back to the MAS. So it should be able to take the information on board and make use of it and conduct searches. As James suggested, search is the most important part of rescue. Many times the rescue part is relatively straightforward, but not always. Recovery of survivors, interesting question about how MAS does that. And if you're lucky, you'll have an air unit come along and lift them up and take them away, but that may not happen. And medical and welfare care, we have already talked about the need to take survivors on board, provide them with welfare capacity and capability and medical care. I'll mention that again in the later part of this. We know about the degrees of autonomy. 2 of those 4 degrees of autonomy may have people on board. And in my opinion, even autonomous vessels may have somebody on board if the ship has people loaded on board to conduct repair operations or for safety or security of the vessel. So there may still be people on these vessels. But degree 3 and 4 are the ones where we are going to rely more on machines and autonomy to do things. But they are a problem for SAR because currently we have people. We talk to people and they do things for us. So the current model is a vessel receives a distress alert, or the shore MRCC receives a distress alert, and we can broadcast to ships and the ships can respond, et cetera, and we are speaking to human beings on board the ship. The new model that comes along may include a shore-based ROC. So we may have either the ROC on board the ship operating the vessel or intervening in an autonomous vessel to operate the vessel for a SAR operation, or we may have both. We may have some people on the ship and an ROC. So we end up with the potential for more confusion. So this worries me. I've been in confused SAR incidents in my past career, and ideally you want less people in it as possible. So there could be problems here. We have to make sure that we know how to contact the ROC if they are in charge of the ship. We may be doing that by telephone. We may be doing that by satellite. We may be going through the ship and back to shore. There are many models here. We have to make sure they work, and the RCCs have to have very reliable information about who is running that ship, if it's autonomous or remotely operated, and how to get in contact with them. They could be the other side of the world. The ship could be in the Atlantic and the operators could be in Japan. So we need that system to work very well. So it's a new process. It's different. It's more complicated than the old system. Obviously, we don't yet know how many mass will be at sea. There's lots of predictions, but all of us know prediction can be terribly wrong. As I say there, prediction is inaccurate. I think in SAR, the effectiveness of mass will depend on the crewing levels and the reliability and performance of the automation and mechanization and the remote operation centers and the personnel in those centers. They need to be properly and well trained. And in my opinion, sometimes the search and rescue part of a seafarer's training is sometimes not as strong as it should be. But we do have guidance for them. IAMSAR manuals being one of them. There are some big questions, and it's been mentioned before. Should a fully autonomous ship be required to recover survivors, or just respond and locate and stand by, drop supplies or survival aids? In my opinion, they should probably be able to recover people because people may be in danger of death. We have to remember that. Other assumptions are if a mass has people on board, of course, it has to then have the correct life-saving apparatus and the correct life-saving equipment. So radios, EPIRBs, PLBs, all the gamut of all the things that we must have now when you have people on ships. A mass with partial crew on board or people on board must be able to recover persons from the water because one of those people may go over the side. And therefore, does that mean we have to have things such as fast rescue craft? And if those people on board are not trained to use that craft, then is that an autonomous or a remotely operated FRC? There are a few questions here. And mass rescue situations in the terms of many people at risk at sea, where vessels would respond today. If we have an autonomous or remotely operated ship with a very small crew, because we could be seeing airline type crews on vessels now, we might see 2 or 3 people operating a ship perhaps as one of the models. How are they going to cope with a big rescue situation, a mass rescue operation? Desired capabilities, Hernan mentioned some of them. So we need to be able to go to the scene of a satellite distress beacon signal. We need to be able to locate the 406 megahertz beacons and any future GNDSS systems and the frequencies being used. The classic radar, SART and AIS SART signals, DSC transmissions. If you have an automatic DSC transmission, you will have a position in it, you hope. And so the ship should be able to interpret that information and respond to that position. And voice radio transmissions. How does a mass hear a mayday by a human being and then do something with it? Does that go to the ROC? Does the mass autonomously and using AI interpret that? We don't know. And any SAR data transmitted by MRCCs. So the MRCCs will be wanting to share large amounts of information with them, particularly for searches. There will be search areas and instructions being transmitted. And the benefit of automation is that we can transmit that information automatically, and the ship should automatically then start doing its search patterns and start doing what it needs to do. But any information sent to vessels at sea by the RCC must be used by the mass. Just a definition there where it says process should include the forwarding of data and signal information to a relevant MRCC in a format that will ensure maximum performance of the SAR system. So I'm implying there we have to have a functional, goal-based function capability. And use implies to utilize the information to proceed to and rescue persons in distress, so keeping it goal and function-based. What about the old-fashioned distress signals, visual and oral? There are sound signals, there are visual signals. The mass must be able, as would a human being, interpret these signals. Whether or not firing a gun and burning something on your vessel should still be a distress signal, we don't know. But if a vessel is on fire at sea and another vessel sees it, they often say, I'll go and see what's happening. So we have to manage this. How are we going to cope? How is a mass going to detect a red flare, for example, and orange smoke? But there is beneficial SAR functionality. We do need to make use of this. There is an opportunity here, I think, for the international community to advance search and rescue and make ships more beneficial to search and rescue, remembering that the large areas of the globe do not have dedicated search and rescue facilities. They rely completely on passing ships. So that passing ships, the global maritime, commercial and military fleets are the search units and search and rescue units. So maybe we should be able to interconnect to the vessel's onboard radio so the MRCC can communicate directly using the radios on the ship to the scene to manage on-scene coordination, et cetera, et cetera. There are all kinds of opportunities here to advance the way we operate currently, because currently we have to pass information to a ship and ask them to do it. Maybe it's easier if the RCC can just communicate directly. And that would be usable for the safety of navigation of the craft to its dual use. James talked about radio direction finding. Absolutely agree. It was one missing thing from the original GNDSS. There should have been radio direction finding, in my opinion. Sorry, I should have just left these as object detection. We have to be able to detect objects in the water. We use the term object because it could be people, wreckage, life rafts, lifeboats, man overboard buoys, pyrotechnic signals, etc. But detection of objects would be very important. And voice communication. Currently, a ship can loud hail. It can project sound to people in the water to communicate with them when they don't have radios. How does the mast do that? It will have to have some sound projection capability, in my opinion, to be able to talk by loud hailing to people, to tell them to do things and prepare things when we are coming to rescue them. Searchlights, yes. Low light night vision systems, high quality zoom capabilities to look at objects and examine them so that the ROC, if the ROC is running the ship, can act as if they are on board the ship. Some of this will be challenging technology, I think, as well. And recover survivors and provide basic welfare and healthcare to them and allow them to be protected. They will be wet and cold and there may be no one on board. How do we look after them? How are they looked after? And the level of care will depend on whether the mast has people on board or not. Uncrewed mast might have to provide equipment, supplies and shelter. As I said, they may have to self-administer medical care and access telemedical advice, perhaps. It's going to be developed. We don't know how to do this yet. There is a great deal of detail in this problem. I'm not trying to be difficult, but there is a lot of detail to be done. And the more you drill down, the more detail you uncover. And recovery systems. We know what we could use. There are conveyor systems on the market or being developed, hoists, ladders, nets, stretchers, cradles, but these have to be self-used by people who have no one else helping them. And the effectiveness and choice will depend on if there is personnel on board the ship. And we still have to test these on autonomous and remotely operated vessels. So quick conclusions. They will be required to take part in SAR, but there's a great deal of work to do. And that work's going to expose new problems and new advantages, because I can see there are some great benefits here if we use it right and if we get the industry to fit the equipment for humanity's sake, for human benefit. And ship owners and operators will have the opportunity to provide improvements to the global SAR system. And I'll just make that point once again. I work for the International Maritime Rescue Federation. We're interested in global SAR, and large parts of the world do not have very effective SAR systems. They rely on the commercial ships to be their rescue, and we thank them for that. The world thanks them for that. That's it. Thank you very much.
Oh God, I need an HND to do it, or a PhD. Really interesting from an expert who's done an awful lot of work on this over many years. Just to reassure you, the smallest unmanned surface vessels have loud hailers, and no great problem. And there are a few other things. Is Peter Lloyd in the audience? Yeah, I might defer to you for one point in question time. I think you can answer a question. Okay, well, we're going to move on to our last speaker, who has been upended in the world, having come all the way from South Africa 2 days ago to address us. He works for SMIT, that's SMIT, many of you will know.
Presentation going to come up there. There we go. I'm on. Great. Yeah, no, all good. Thank you very much, James. Thanks for the introduction. My main focus is going to be having a look at another part of search and rescue, which we use basically work hand in hand, and that's salvage. And both using search and rescue and salvage and how we work together on things. Yeah, next slide. Okay, I'll first start off just by saying what salvage is, then going into Salvage and the Coastguard, how we work together and we complement each other, and then salvage and autonomous vessels or autonomous ships, and then just some of the challenges as well as the opportunities that we are faced with this new upcoming part of our industry. So, yeah, next slide. What is salvage? The IMO defines marine salvage as a voluntary response to maritime peril by others than the ship's crew and from which the ship or property could have been solved or saved without the efforts of the salvor. So I won't go into too much detail about this, and there's a number of key aspects in the definition of marine salvage, from the voluntary side of things to the actual fact that you have to salvage something. But the fundamental objectives of marine salvage is basically to save lives and property, and very specifically in that order: lives before property, and then while doing so, protecting the environment. So those are the principles which salvage run on, and that's where it is defined. Okay, next slide. Just to tell you a little bit about SMIT, the company I work for. We've been around for a while, since 1842, so we're just on 180 years old now. We're one of the biggest salvage companies, or are the biggest professional salvage companies in the world. We have strategic offices around the world, and when I mean strategic, it's with the effect that we can be able to render a response within 24 hours of getting a call. And that's why we have, where you see those little logos, the SMIT signs there, those are offices where we have, and that's where we deploy crew, vessels, as well as equipment and people from these offices to respond to anywhere in the world. And then we also rely heavily on our holding company as well, which is JLIS. There are a number of aspects and divisions within that group that support us, as well as joint ventures and local agents. And all of this in combination hopefully renders a effective response to a vessel in peril. Next slide. Just some of the main casualty types that we faced with on general, you get your groundings. Usually either it's one of two things. It's mechanical failure and the vessel drifts onto a reef, or just an error in navigation and the vessel runs aground. Collisions, yes, they do happen. Ships do collide with each other. And fire and explosion, which we are seeing a lot more of these days, especially in the past year or so, specifically being RoRos with electronic vehicles. We've had 3 cases in the past 2 years, and that's increasingly what our work is on fires and explosions. And then obviously flooding. Sometimes they're in combination. You can have a grounding, then a fire and explosion, and then a flooding. They all work together. You can have one or all 4 of them at the same time. So, we have had a case where there was a grounding, another vessel collided with it. There was a fire on board and then a flooding. So yes, they do happen. Then moving on to the next slide, please. Now I'd just like to go into some of the roles and the collaboration we have between Salvage and Coastguard. It is quite important to say how we work together. It's a combined effort. Whenever there's a vessel that's in peril, 9 out of 10 times the Coastguard or an authority will be involved in it. Just to identify the primary roles, the Coastguard is a government agency responsible for the maritime safety and security and environment protection. In emergency situations, they play a primary role in search and rescue, ensuring the safety of life, protecting and making environment or marine environment, and maintaining the navigational safety. So that is quite clear, and I think everyone knows what the primary role of the Coastguard is. Salvage, on the other hand, we are private entities or individuals with experts, and that's both with vessels as well as equipment, and they may be contracted to assist in the recovery of assets, mitigating environmental damage, and minimizing economic loss. So 2 fundamental differences in our primary roles, Coastguard being a government agency and Salvage being on more of a private entity side of things, but all working together on a common goal. The collaboration between in an emergency response, and that is, I've specifically chose these 3 pictures that you see here. These are all cases that we've been involved as SMIT. You see all of them have an entity of the Coastguard assisting us, whether it's one of the cutters that was first on scene of the vessel when there was one on fire, or getting onto the vessel. As Salvage, we're a big company, but we don't own helicopters all around the world. And that's where we rely heavily on authorities wherever these vessels find themselves either run aground or offshore, that we go out with the Coastguard. Their objective would be to get the people off, and then we would be getting on board the vessel to try render and save the vessel as is. So part of the thing is the early coordination. The Coastguard and the Salvage often collaborate from the early stages of the incident. The Coastguard may request that the assistance of Salvage based on the nature and severity of the emergency. When it comes to early coordination, sometimes the Coastguard or the government agency receive the call first. They effect or render a response, and then they say they're going out to recover the people. There's vessels on fire. You need to be rendering a response, whether we have to get firefighting vessels, we need to get firefighting crew out there. So that is where we share information. Or often what happens is we get a call from one of the owners or underwriters, and then we already start on our response to the vessel, but then have to inform the local authorities and Coastguard that there is an incident and we need their assistance in saving the vessel. Then resources and expertise utilization. Salvage bring specialized equipment, knowledge, and experience in dealing with salvage operations. and the Coast Guard can leverage these resources to enhance their own capabilities during complex incidences. Like I said, we have officers around the world, and those officers have specific equipment and people trained in those offices to render the response, and we often use those resources to support any, whether it's just a personnel recovery from a vessel. So the collaboration between the Coast Guard and Salvage is built on a foundation of shared responsibilities, expertise, and resources, ultimately contributing to a more effective emergency response and maritime safety. In the next slide, which is going to come on, is going to be a video, just a few minutes of just highlighting the realities of how things work out offshore, that it's not always smooth sailing. This is footage taken from a number of our incidences that we've responded to in the past few years. And then I think after this video, then you can also put in perspective of how MASS is going to have to operate and function in these conditions, and as well as being able to handle them, actually. So yeah, to the next slide, please. Thank you. So I think that just brings some of the realities of some of the incidents, that these are real life incidents, what happened. And yes, it's we need to be prepared for these things. So moving to salvage and unmanned vessels, as they say, the root cause of marine incidences, they say, is 75 to 80% is human error. And there's been a bit of controversy saying that, okay, now with a fully autonomous vessel, now are there going to be 75% less incidences? It's highly unlikely. There are still going to be navigational issues. There are going to be, there's going to be, I'm going to say, mechanical issues. So there will still be incidences coming, and they need to be prepared for that. So the potential areas that, like I mentioned, incidents that will remain with MASS, and whether that comes in from cybersecurity, which we had a great presentation earlier today about it, to communications, how they're going to function when there's a loss in communication. So these are some of the incidences that we've been looking at of when the incidents with MASS happens, how we're going to respond to them. There's nothing new regarding salvage of abandoned or unmanned vessels. We often have that, and as you saw in the footage, a lot of the instances, the crews are evacuated. We put our crews on board there, and then we do our thing of either making a tow connection, reestablishing power on the vessel. So that we don't see anything changing in that side of things. But then the contracting is also to expect to remain the same, but legalities, that's going to be another whole ball game of things, because you're looking at liabilities and responsibilities. That is, I think, going to be another whole. If I had to start going into that from the salvage side of things, we could be here for the rest of the day. So I won't get into that, but that is going to be something that's going to have to be looked in more specifically as time develops regarding salvage and unmanned vessels. Yeah. So just some of the challenges, like I mentioned there, communications being affected by a cyber attack, jamming and spoofing. You heard those sides of things. We had a look at it, and I think the reality, and I can be made under correction here, is we don't see someone having a cyber attack and taking full control of the vessel, then sailing it away. We saw it more of jamming and spoofing and cutting that communications link. So with an autonomous vessel, if you cut its communications, which can quite easily be done, what does the vessel do? Is it just, does it go into we can call it limp mode, it stays stationary? What is the default of it? Will it stay in the same position? Will it just drift? Will it still be able to give off a signal of what its position is? These are important things for us, because if we don't know where the vessel is, it is extremely hard to find it again. I was involved in a salvage earlier this year. A vessel was abandoned, fire on board in the Mozambique Channel, and it took us 2 weeks. There was no sight of it, and eventually it was determined that the vessel had sunk. But 2 weeks of searching till we could actually determine what happened to it. So even in this day and age of technology, it is very hard, if you lose communications with a vessel, to find it again, unless it's in a very busy shipping lane. So receiving up-to-date and critical information in an emergency, when we get a call from a vessel that's in distress, we then have to get real-life information from the master, from either the chief mate, of saying what is on board, what is the condition of the vessel, actual data on, okay, is it a crack, and then that's how we formulate our response to it. If you don't have that communication of knowing what's actually exactly wrong on board the vessel, it's going to be very hard for us to effect a proper response. We can send our entire warehouse to there, but that's not practical. We need to know exactly what equipment and personnel we need to send on board. Effective efficiency of communications, that's on the latency and failure and data integrity. That's, I think, goes hand in hand of getting information. Then speaking to a remote control center instead of a master over the VHF. When our crews want to board a vessel, you're always talking to a master saying, get your vessel onto a set heading. We need, okay, the conditions on site are a bit different. In that video I showed, there was the Ames half lift. Well, that's the one that where they were taking the crew off. They left the vessel with its DP running, and now you need to position the ship in a good position to get the most stable platform for you to land on board. And if you're not being able to speak to someone directly, it's very hard to be able to get on safely. Then there's also, goes back to that efficiency of the latency. So let's say you're speaking to someone at the Rock saying, okay, the vessel's now at a heading of true north at 000, you need to change direction 10 degrees. Now, are you sitting in the helicopter trying to speak to someone in an RSC? That's just not going to be practical. So those are some of the challenges we see. Then requiring a clear and thorough report of hazardous areas on board the vessel. So we're going to need that information before you put a salvage crew and also a rescue crew on board of, are there any hazardous areas on board, hazardous cargo? What areas do we need to avoid going when we go on board there? That's important information, especially when we put people on board there. We just don't go on board a vessel blind. Then the perception of danger. who and how is the salvage situation determined? So are you going to have cameras everywhere and you've got a bilge alarm saying you've got flooding in one area? Let's say you're flooding in an engine room. Is the flooding half a meter or is the entire engine room flooded? What are the sensors that we need to know of, what's happening on board and a true reflection of it? Next slide. The other one is the access to the ship. I'll just go through quickly on it. These are nice, beautiful designs of autonomous concept designs. I like to think them like the Ferraris of the ocean. But one thing is, how are we going to get on board there? You saw some of those conditions of people trying to get on board there. Let's say in about a 30-meter waves and force 14 or whatever you want to call it, trying to get on board there. That is going to be extremely challenging. Then gaining access and breaking into the system. These systems are designed to not have people get into them. One of our factors, how do we, let's say, when we get on board there, is we break into the system, we get the engine running again, we get auxiliary systems running again. Do I need to send a technical IT buff down with some of my roughneck salvors? So those are the type of things we need to think about. Then also making a tow connection. As you can see, all these bows are nice streamlined things, but making effective communications between you and the tug and trying to make a connection onto there, those are some of the practicalities we're seeing as a challenge. And then, are the suppression systems on board adequate? That I can go into quite detail of this, is that it's designed for not having people on board there. Your suppression system is, are they going to have CO2 suppression systems throughout the vessel? That means then when our crew get on board there, can they go into those spaces safely, or do they have to vent everything? This is in case of a fire. And then also just some of the tank sounding side of things. There's no one manually taking soundings, because I've been on many ships that they say, no, it's the electronic sounding said this, and you do a manual sounding and they're very different on the tank spaces. Next. Another one, also can go into a lot of detail on this, is this alternative fuels. This is going to be a very challenging part of our side of things. It's just that there's so many different alternative fuels going out there: LNG, methanol, LPG, ammonia, hydrogen, lithium-ion batteries, and the list goes on. And all of them have their different challenges. And this is that we need to start working on response plans of these different alternative fuels, and how we as salvors going to either mitigate it from either exploding or leaking out into the environment. Next slide. So, almost wrapping up on things, just some of the opportunities we have now while this mass is still being developed, and it is developing very quickly, is salvors to get involved in the design, training, and operational planning and trials of autonomous ships to make their concerns and requests known. That we put our concerns forward, and then they put their concerns forward, and we figure out how best we can put it all together. And initiate communications between owners and operators before the incident happens. So you've got a certain vessel, you come to a salvo and you say, okay, this is my vessel, it's on this fuel, it's got this system on board. If anything happens, be prepared. And we have all that information up front instead of asking it, and we can prepare accordingly. And then remote assistance to incident on board before they get out of control or require personal or vessel response. That is an important one, is telling us earlier, a salvo earlier about an incident than rather later. Don't tell us when you are 50 yards from running aground. Tell us when the day before when you had a mechanical failure. That's the important part of things. And the goal should be in providing salvage service to an autonomous ship is no more difficult than doing it to a traditional vessel. And that is the ultimate goal that you want. And just out of interest, I put that picture of the Yara. I think everyone in this industry knows the Yara Birkeland. They've been really clever of putting a towing arrangement up on the bow. It's probably a bit of an afterthought there, because you wouldn't have that normally if you designed it correctly on there. But that will be a very important part of autonomous vessels, of having either an emergency towage pickup system either on the bow or the stern. And these are factors that make our lives a lot easier. So if anything ever happened to the Yara, we know she's got a emergency tow connection up to the bow, and then you can make a connection a lot easier. And that will take you within an hour, you can make a connection. But if you have to set that up on a dead ship, that's taking multiple hours, half a day to try to set up a tow connection. So those are some of the small details that you can discuss in the early stages of this. Yeah. And then hopefully I made it in time. Any questions? Yeah. Thank you. Sure.
Thank you very much indeed. And is that you in the picture? Yeah, yeah, right. We must have a chat actually about the code. I'd like that. Now, we finished ahead of time, which is great. Well done. And so we've got time now for the panel. And if I'm able to work this computer, which I was able to, but it's all in Japanese and I can't find the questions, they've disappeared.
Here. Questions.
No, there were questions. Let's have a look here, see. Where have all the questions gone? Well, if you're out there in the ether world, please put your questions. There were a couple there and I've lost them. I can't see them. They've disappeared. The two questions have disappeared. Tech failure. So let me throw it open. You've heard a lot of experts talking there about search and rescue. Thanks. I am going to start with a question from, I'm not quite sure where, but whoever it is, Kian, in terms of artificial intelligence, how does the decision-making process of unmanned vessels during SAR differ from traditional manned approaches? And there's a sort of part two, what ethical considerations arise? So, Rowley, let's see whether you've got a view on that. Take the ethical question second, and the first one is decision-making.
Okay, thank you. I don't know the answer to that. I guess that's the discussion about how AI is going to affect the world around us anyway. How is it going to be used to help to make decisions? If there is an autonomous vessel which is programmed with artificial intelligence SAR responses, then there's going to be a lot of trials required and a lot of testing required. So I don't know how that's going to affect that. There are other people, I guess, in the community who would have a more technical answer. Maybe the Tokyo University have a view on this. The second one was ethical. I suppose we would be programming, if I'm understanding the question correctly, we're programming the robots, so to speak, to respond and assist humans. And there's plenty of sci-fi novels out there about that. So I don't know, is anyone, do you have a view?
Do you want a view?
Oh, well, there is a duty to comply with. I'm not going to enter into ethical questions, but there is a duty to comply with, to render assistance. And just before we pointed out, this is not to fulfill a valid result, but to use Endeavor to complete it. So, I mean, to address these duties from an ethical point of view, will be approached on a legal basis more than a philosophical side. That's to comply with. Are you complying or not? Are you going to render assistance? Are you going there? Are you going to try to pick up the people from the water? But I mean, it's the most practical way to address it, because if you go to interpretations, you might have as a big number of interpretation as interpreters you could have. So, I mean, mostly it could be done from a practical point of view.
Okay, and there was a sort of associated question, you know, where the RCC is unable to maintain real-time comms with unmanned vessels, what fail-safe mechanisms and autonomous decision-making capabilities are in place to ensure the success of the SAR operation? I'm talking too loudly. I'm going to answer that one because, you know, I'm in the middle of designing unmanned vessels. And of course, the great thing about them is that they have redundancy built into them in every regard, and not least in terms of communications. In my humble opinion, the chances of the RCC losing communications with the unmanned vessel is the least of your problems in an SAR operation, because there will always be other ways that you can talk depending where it is. And I think we should put mass into a sort of context. We are really quite a long way from talking about ocean-going mass. Some nations are thinking about it, and I accept that, particularly in the Far East. But the majority of them will be short sea and will be within range of a variety of different communications means, whether it be VHF or mobile phone or whatever. So I think the chances of you getting to the point where the RCC can't communicate with the unmanned vessel, it's pretty low down in the priority list. I'm looking at the live audience here in Japan House in London. Does anybody wish to comment on either of these? Yes, I have a hand up. Could you say your name, please?
Thank you very much. Good afternoon. My name is Motonobu Tsuchiya, working for Liberian Registry. Liberian Registry or Liberia has been raising a few questions at IMO level about the communication.
Sorry, can we turn the microphone off?
Yeah, on network governance. So as Commodore Fanshaw said, there is a almost nil opportunity chances that the RCC will lose connection to ship, because that has been protected and prioritized under GMDSS scheme. However, when it comes to mass operation, mass control, there is no such internationally agreed communication scheme. So we raised that question to IMO and still doing some bilateral discussion with stakeholders. One of the response we got is, oh, don't worry, if the remote operation, remote connection is lost, mass will go to autonomous mode. So connection or network capacity reliability shouldn't be a problem, is one of the answers I received. But looking into those presentations, I have a feeling that during search and rescue operation, autonomous operation, AI will decide everything, every detail about every single action of the search and rescue operation seems to be very difficult, if not impossible. So all mass has to have remote operation capability if we are looking into the search and rescue operation. Is the observation I have thanks to your presentation this afternoon. So if that is the case, each mass has to have stabilized, stable network connection and has a lot of capacity of the burst, because it will require visual content transmission on real time. So our remote operation center and mass has to have a lot of network data capability. So I just wonder if you could elaborate some of those thoughts. Thank you very much.
I'm going to ask my panelists if they extracted a question really from that. I didn't. Yeah, a comment. Really, a comment.
Yes, just reminding ourselves that if there are no people on board, SAR is kind of not interested. It's salvage. But we would be perhaps looking to use a remotely operated or autonomous vessel for search and rescue response. So I guess if the vessel is in good condition and undamaged, then the reliability of communications will be guaranteed. But when things go wrong, if there are people on board, as we see from videos and when we know from experience, comms fails. I've in my previous career, lots of times we couldn't communicate effectively. We had lost communications. So I'm unconvinced at the moment about this guaranteed reliability. We'll see. I guess, so, thanks.
Okay, never let it be said that comms always work, but if you have redundancy, then you have a better chance. That's all I would suggest. Out there in the land of ether, I can't see. There are lots of you. I know exactly how many because I've got a list here. So do pump your questions in, and we'll try and address them. But are there any questions? Yeah, I see one in the middle of the room there. Can we get a microphone? Oh, okay.
Yeah, sorry about that. Andrew Drewinger. Does the panel see a need for some kind of SAR training for the operators of remote vessels, and to what sort of level? Yeah, what I was asking, the operators of remote, of unmanned vessels, will they need some element of, should they have some element of SAR training to be, if they're going to be, part of a SAR rescue?
We included some reference that the remote operator center operators shall be trained on search and rescue procedures. It was included initially at the section 10, but after a first review of the whole mass code, the part 3, where the specific standards are set, it was considered that these questions of training shall be addressed in the future. I expect in the summer, because we have no much time, about the human element issue. It will cover the question of training for operators on search and rescue procedures, because it will be really important to address that. Because, well, the question, not on the question of salvage, where there is no person on board, as Rolly pointed out, but on the question of the mass crew of a remote operation center going for SAR operations, how to communicate and how to address the difference of not being on board. It's addressed just to include references to the EAMSAR code and many other issues about specific procedures and communications and so on. But it's considered, but will be treated on the next months. I mean, after MSC 108 will be addressed, because it's a main point of the question of training of operators. Yeah, thank you.
Just make one comment. I'm not sure how much search and rescue emergency response is in STCW. And of course, majority of ships proceed throughout their life, and seafarers never have any search and rescue operations. So it's a little bit like firefighting training, or maybe less so. Firefighting training for crews is that you practice for something you hope is never going to happen, and most ships never have it. So as a SAR person, I would like to see more training by the crews of ships, but it's up to IMO to discuss. And I think we have a golden opportunity here with the debate in the mass working group to talk about these things and ensure, as I said, the detail gets done.
I think the point that bothers me is that it's equally applicable to people who are in ships embarked, as it actually is to those that might be in an RCC or a ROC when something like this happens. So it's an example which I've seen in the past, where people are tending to sort of use the mass example as a trigger for a much wider discussion. And I think we do have to bear that in mind. I mean, the reality is that if you went on any manned conventional type ship and asked, what training have UO deck officers had in the whole business of SAR, they might be able to talk to you about what they do if a helicopter appears over deck or whatever. But when it comes to the business of SAR, from personal experience, I can say that you do an estimate and you take stock of what's going on around you at the time, and then you adjust to it. And no one situation, and I'm sure Richard would agree with this, is going to look like the last one you dealt with. So there's a balance here between what you can train for what you can think about, and procedures that you have to adopt if you're put in certain circumstances. And I cite the helicopter one as an obvious one.
Yeah, I think also just complementing on those is a lot goes into also the STCW standard training that they have. There is that search and rescue element of it. And then either you elaborate further on that. But in our experience is that it also comes down to the vessel operator itself. It's the responsibility of the owner to train his crews on, okay, if these are the emergencies on that specific vessel, and what to do. And it's not, I think it's not just limited to search and rescue, it's also from damage control, emergency response. And those are all in one thing, so there's certain owners and operators that are regularly doing tabletop exercises, either engaging with salvors or authorities and training their crews. But then obviously we've got ones that it's the first time they've ever heard about emergency procedures, and they just know about one number they need to call someone ashore. And no, Dory, that it'll get all sorted out from that one person, the PPA. No, it doesn't happen. It's the vessel itself. So yeah.
I think that's a very fair statement. There was a hand, no, I'm sorry, there was a hand behind you, sir, if I could just get the microphone. You're all in the dark to me, but there was certainly a hand I spotted earlier, so just bear with me. It's about 3 along. There we are. Yes, sir.
Yeah, hi. Sorry for the back. My name is Danilo Di Pietro. I'm working in Frontex, European Agency for Coastguard and Border Control. And I'm also Lieutenant Commander of Italian Coast Guard. Now, I completely agree with you that unmanned system will be the future for search and rescue operation, search most than the rescue at the moment. However, from operational point of view, I have, from the operational point of view, I have a couple of concerns regarding the artificial intelligence, and I'll explain you why, and we need to map a little bit in one scenario. If the ships will be fully autonomous, so as understood correctly, the vision will be that this ship will develop its judgment to render assistance to the search and rescue cases. Now, imagine that in Central Med, the problem with immigration, overcrowded boat with migrants are really risky situation that can be floating a vessel, but in a snap can turn in a shipwreck. So if this vessel is approaching migrants boat, understand the possibility of rescue operations. And like we discussed, these ships might be equipped with life raft, goods, drinking water, whatever, to render assistance. And if it's going to deploy the life raft, migrants can jump in and maybe make the ship overturn, and a disaster will pop up. So in this case, would be who is the responsible for? With the liability in this case might be really a problem. And another scenario that I'm a little bit concerned. I'm an helicopter pilot, and thanks for sure the shipwreck on Sardinia on Sea Dry Blue. Yeah, for example, in that case, the ship was run aground. But usually to approach a ship, either if I need to rescue somebody, if I need to drop the rescue swimmer, I might ask the ship to maneuver, to put myself in a better position with the wind to make the approach. Now, in this case, when we talk about the communication between the rock and the ship, yeah, for example, how me, pilot, can command to an unmanned ship, completely autonomous, to, hey, can you drift a little bit 30 degrees on 330? Because I need to make the approach. Or can you slow down the speed? So I know that are quite practical, but in developing the concept, I really hope that the operational entity like Coastguard will be fully involved, because might be help you out to develop this concept once the legal framework is going to be set.
So if I understand you right, there are two parts there. One is your concern about responsibilities when you're dealing with migrant
Correct.
boats.
And then another one for the communication.
And the other one is how you might talk to a mass from a helicopter. From the latter point, I think I can safely say that you will be able to talk to the mass as if you were talking to an ordinary ship out there floating around doing its thing, because the comms will be available. And even if you have to revert to a standard VHF channel, you will be able to do that. And that's what they're all configured to be able to do. So I'm far less concerned about comms between the helicopter and the mast, if that's what's required, because that would be part of the standard suite of communications in certainly the smallest of masts. You know, I'm talking about the 710, probably the 12-meter plus size. And once you get up to short sea and 100 meters, it absolutely is part of the deal. You raise an interesting question about a subject which is quite well covered in some of the journalistic articles. And that is that you've got a boat full of migrants. Let's say there are 20 migrants on a very ill-equipped rubber boat, which isn't faring too well in a moderate sea. It doesn't matter what state of sea it is. And who has responsibility? I defer to the experts really to give a view on that. Look at these two. Look at them. For those of you who can see what's going on the panel here, they're both going, yours. But let's have a crack at answering that, because I'm not sure there actually is an answer, but over to you.
Well, it's just considering it's a full autonomous ship or remote operated ship without crew on board, carrying out a rescue of persons in distress, in this case, immigrants, the case you say. Well, I mean that using the endeavor to rescue these people in distress, the systems they use, you're taking people from the water. I mean, the systems you use, you are not there to hold the people to get up. So, I mean, the responsibility will be difficult to put to any persons. For instance, the lack of maintenance. If the systems to retrieve people from the water later pass the ball to Roland, if the systems are approved to recover persons from the water, or from a life raft, or from a fast rescue boat that you launch, and so on, I mean, may not affect the people who is remotely operating. If there is a failure while they're manning some of the systems that hoist the people from the water, it could be for sure. But if there are automatic systems approved, well, let's see if the approval procedure is bad. But I mean, it's not be the part to be liable, to put the liability on the responsible of navigation. I also want to point out one question that I passed to Motonobu Sushicha some months ago, some weeks ago, about the relationship of the SAR section with the security section, because putting persons in distress on board on an unmanned ship will make to face new situations that the people is recovered from or rescued in these places on board the mast without crew on board, may try to access to restricted areas of the ship. And this brings a new issue on security. That it happens, I mean, in Italy, it happens also in Spain with the rescue of migrants. Usually there were situations where the crew is threatened by the rescued people. So it's a question to address, this question of the access to the restricted parts of the mast, also to consider, because we may need to check if there is something inside the boat that may help us to survive, or we don't know. So there are new questions to pose there. But going back to the question, I mean, the systems you use, if they are approved, will not be a hurdle to overcome. But I mean, Roland may address about the systems that can be addressed from the water if
I think this is a difficult question. It's going to have to be discussed. I can see rescue centres deciding to have procedures whereby they will prefer to send a manned, crewed ship to these sorts of incidents if they are available. So if you have a autonomous vessel or remotely operated vessel and 2 or 3 manned vessels, then you will say, well, let's send those because we know the remotely operated vessel has restrictions because it can only offer a device to allow people to self-rescue. And in these situations, they may not fully understand, there may be confusion, there's all kinds of scenarios here. I thought about this earlier, these things need to be tabletopped, they need to be analysed and tabletopped and worked out, and the lessons and the ideas collected together, because there's a lot of, as I said before, there's a lot of detail to be done here, and I don't think we have all the answers.
If I can offer a horribly practical point of view, the chances of a migrant boat in this scenario being very far from one of the fairly well-restricted and well-defined coastal areas is very small. I mean, they're not, from my knowledge of dealing with Border Force and various other agencies, they're not out there in the middle of the deep blue sea, you know, doing 70+ mile transits. So I would assume that there would always be some kind of manned alternative, and certainly that's what I understand the planning is based on. If we can sort of move on from migrants, which is a very, very difficult topic, and the trouble is there are so many moving parts, and I can hear the lawyers getting excited as I sit here. Now, there was a hand sorry, can I come back, Peter? Can we get the microphone to the gentleman with his program up? To those of you out there watching, oh, we've got a new question. I'll go to you, the ether question in a minute, but I stalled the guy who's about to speak. Yes, sir, your name.
Yes, thank you. Osamu, a resident in London with some maritime interest. Thank you for this excellent presentation. Fascinating to observe how we are trying to facilitate the smooth running of near future introduction of unmanned vessels at sea. And I note from presentations that the global regulatory bodies, IMO, the MARS code is soon to be adopted, and it's a very mature final draft is published. And according to this, the SAR section, the dedicated SAR section, which is in chapter 10, is only 3 sections, not that extensive. And it's really a skeleton, if you like, basic, in order to allow the unmanned vessels or MARS to operate in the field, in the mixed environments whereby lots of merchant vessels with highly trained seafarers and masters on board. I am hearing that the idea is this MARS code to be adopted this year. And my question here to the excellent panel in front of me today is, what will be the most pressing issue in terms of Coast Guard operations, in particular search and rescue, after the adoption of the current version of the MARS code, in order to make sure that the search and rescue service is in place around the world? If I made it clear, thank you.
Can I answer that before passing it to the panelists? I mean, I think we have to keep this code in perspective. It's a voluntary code, which we expect to be published this year by IMO, and it will not become mandatory for 3 years, and it can't be less than 3 years after that, during which we'll have had time to examine all bits of the code. I'm sure one of the sections will be the whole question of SAR. But the reality is that within the SAR definitions is the word, you know, is able to, I forget the exact quote, but is able to do things reasonably or whatever it is. And so we mustn't over-egg the capabilities of any particular mass. And I would fall back on the fact that it's more likely to be involved in the search phase rather than the rescue phase. But it could well be involved in the rescue phase as a scene of action commander or whatever it is. So what I would resist is being too prescriptive and saying mass will do this, that, or the other. I haven't seen the IMO mass code, so I can't comment on the bits that you may have had sight of. I haven't seen that yet. They're playing it very close to their chests, and a lot of it isn't written. So we have to wait and see what actually comes out. But what would you say?
Thanks. Well, the first is that the mass code at this point doesn't address the level of autonomy. It set the goals that should be achieved. And the functional requirements established according to that try to address this question from the perspective of goal-based standard, not too prescriptive. Just you shall fulfill this duty. How you do it? Yes, combines us that you are fulfilling it. And also the other question, just consider that the mass code applies to the mass, to the ships, not to the whole SAR system. The mass shall comply with the duties you expect from search and rescue from a conventional ship, but it doesn't apply specificities to the search and rescue system itself. So just going on the question that James pointed out, it's not going as the first version shall be delivered by the end of this year. It will be recommendatory. I mean, a lot of questions may remain open. I mean, it's my opinion, my personal opinion. Let's see what's happened in the next months. But well, I don't know if my colleagues want to add something on that.
Yes, thanks. I think I agree with James. If we have to choose, the most important thing is search capability, because the autonomous and remotely operated vessels may have better technology than current ships, and we're often searching for people. Despite all this, we're taking the search and rescue. I heard that 30 years ago, and it hasn't gone away. We still go looking for people because they've lost their technologies. And secondly, I think if I remember rightly, the mass code says vessels shall respond to persons in distress. What does respond mean? And we've talked about what response means, all of that technology and capability and procedure and process. So, thank you.
Yeah, just to add from a small comment to that is, I think that the code is, it's really just to highlight its obligation. So let's say a mass vessel is passing by and gets called upon from the MRCC. It can't just continue its way. No, I've got no people on board here. I can't do anything. I'm just going to continue on way. I think where the mass code will be addressing something is you have an obligation to get on site there, whether it's just purely searching and spotting to do something, that you cannot waiver your right of that obligation to respond just because you don't have any people on board. I think that's the main objective. The nitty-gritties, which is going to be coming on later on, and the specifics, that'll come in at a later stage. But I think what it's going to address is that initial part.
Thank you. And there's a question on the web. Considering current technological level, I think that it's difficult for unmanned vessels to fulfill obligations of SAR convention. Do you think how many years will it take to catch up? I think we've actually just addressed that very point. It's not necessarily a question of how many years it's going to take to catch up. It's a question of what capabilities can they actually offer. And there will never be a catch-up as such. I'm going to stay with the web before I go to another question in the house here. Somebody, and I'm afraid I'm looking at a Japanese computer, so I can't possibly read it. But the question's in English, thank heavens. What do you think are the main legal challenges of mass that will need to be addressed by IMO and individual countries? I mean, that is a massive question, which, you know, for those of you who were planning to have dinner before midnight, you know, there's a half-baked chance we might be able to address it. I mean, it's a subject all of its own, and all I would like to say is that the legal side of IMO is working extremely hard in very close timing and concert with the other bits, the MSC and so on and so on. And from what I'm hearing, we're not seeing huge legal challenges because, as we had explained by our speaker this morning, you know, quite a lot of the things that were challenges 5 years ago are now no longer seen to be challenges. And the question of hearing and so on and so on, and this idea that it's the vessel, not the person, and that therefore you can use technology. And therefore, if I'm quoting that individual right who spoke, there's no need to actually change coal regs per se for that reason. I think that's a very good example for whoever asked this question. I'm sorry, I don't know who you are because it's in a language I don't speak, probably never will do. All right, we'll move on. I had a question from the House. Yeah, Peter, I think you had a question.
In fact, it's answering Toshaki's question as well. There seems to be at the moment this sort of tension between technology and regulation. And the regulation seems to think that technology is not going to catch up. Sorry, is that clear? I need to be closer, James. Sorry, apologies. There seems to be a tension between technology and the regulation. And the regulation perceives the technology is not going to be there. And I think there are elements out there already proven that can actually show that there are better object detection to find people in distress in the water remotely. There is a capability of recovering people from the sea surface remotely, and there's the ability to protect them from the sea surface remotely. So I think the capability of MAS seems to be hindered at the moment because of the perception that there isn't anything out there that can do the job. Surely the regulations should be challenging the industries to produce this stuff so it can be done. So I keep on seeing ideas that says, oh, well, if it comes available and all the rest of it, unless the regulations push it and actually demand it, where is going to be the will to do it? So it really is, you know, where does the panel see the balance between regulation being setting the scene and the positive scene for search and rescue for the future, as opposed to technology fighting to try and catch up?
That's a good question, isn't it? The business of the regulators coming and saying, well, what we really need is this. Can you produce it? Unfortunately, I don't see that that's a very practical way ahead. What I think is more likely is that systems will be brought into service by individual operators and owners with capabilities. You just mentioned the ability to recover people remotely. Did I understand you right there?
It's already been proven that a remote asset has recovered somebody from the sea surface, as in completely remotely, through, as Rolly mentioned, the conveyor system.
So this is a conveyor system that comes along and you jump on it and...
You don't have to jump on it, it can actually be pulled out of the water.
Or you're
pulled out of the water. So, you know, the remote assets, you've already covered the smaller MAS ships that are out there. Those can be launched from a mothership quite easily. So what we're saying is that these technologies exist in other areas supporting other industries at the moment. It's pulling it all together to support the MAS side.
This is where the dialogue really has to kick in. I'm going to pass it down the road. Richard, do you have a comment on that?
Yeah, I think a lot comes into the fact that I know a lot of the designs that come out there, they're saying they've been restrained by legalities, it's not getting caught up. But I think it is important what you said of the regulator needs to ensure that it covers a certain amount of safety aspects totally in general, saying that we need to tick these boxes of certain requirements, and how you do it, it's up to you of meeting it. It's a classic example of, let's say, an emergency towing arrangement. You have to have an emergency towing arrangement, okay? He puts it on board there, whether it's a Smith bracket or it's a line, but how are you going to deploy it? It's those are the finities of where I think the regulator comes and says, you need to have an emergency towing system that can be automatically deployed. And how you do it, whether it's a certain design or it's system, then it takes it forward. I think that's working more together of the requirements. Yeah.
Yeah, I agree with Richard. I think that the regulations need to eventually go further. At the moment, it just says vessels shall respond to persons in distress at sea, and the very generic overarching requirements. And we do have to go into the detail. We need to be able to locate the devices that are in the GMDSS because IMO mandated them. and we need to be able to recover people, and we need to be able to detect objects on the sea, as would a crew member on a ship with their eyeballs. All of that needs to be developed into the detail. Currently, it's all very strategic and high level, which allows manufacturers to offer solutions, and I'm a great fan of that. Put the problem out there, make them goal-based and functional requirements, and let the manufacturers deliver solutions.
Okay, I think it's time for the panel to be rescued at sea. We've come to the end of this session, and you've heard three really fabulous presentations, which I hope have put markers down for you to go away from this conference and think about. Each time we do these sort of meetings, new things come up and people go away, and all of a sudden results and output is achieved, you know, almost osmotically. But could I ask you please to thank the three panelists that we have here on my right in the usual way. And before I get lynched by our Japanese hosts, I'll shut up. Okay, thank you.